Okay, so today we are going to be doing area between two curves. We only have a couple lessons left until we hit our review for the AP test, which will still be happening. We'll get more details on April 4th, how that's going to roll out. As a reminder, it is just a 45-minute test that is completely online. And I will be doing something similar for those who have not signed up for the AP test. What you'll do is you'll upload it, save it, and then put it online. But like I said, we'll do more details there. Okay, so this is our last chapter of the year. We'll start off with the area between two curves, and then we'll move from there. If you have your TI calculator, please open it up. I also was through that survey that y'all did today. I noticed a lot of people are just using their phones. If you have, unfortunately, I don't have a program for Apple products, but if you have an Android, you can download an app called WabbitMu. That is a way of having a TI calculator on your phone. So hopefully that will help you out. Okay, so today is finding an area between two curves. Essentially, if I have, let's say, this curve here and this line here, and I want to find, let me see if I have a highlighter. My goal is to find this area right here. That's the area I want to find. We'll call it region R, or you can call it A, whatever you prefer. So what we're going to do is, if this parabola is y1, this line is y2, we are simply going to go y1 minus y2. It's top function minus bottom function. Here's my value of A. We'll call it the x value A and x value B. These are the x values at which the two functions intersect. So my integral will be from the lower x value to the upper x value. This is how we find the area between two curves. This is a pretty straightforward topic, so I'm not going to do a lot of examples, but what I will say is that it does apply later on in the future, so please make sure you make a note of how to do this, because we are going to do what's called the rotations around axes and things of that nature in a little bit. Okay, so let's actually go ahead and do an example of this exact situation right here. Sorry, I'm just trying to have a timer up so to make sure I don't exceed my limit. Okay, so what we're going to do first, let's take, let's see here, 2 minus x squared. That'll be our parabola right here. It's not the exact one, but it's close enough. And we have g of x to be the value x. Now, you have a couple of options here. What we can do is we can graph it in our calculator. So we have 2 minus x squared and the value x. Oops. And we can graph that. Well, when we graph that, we can clearly see that the parabola is the upper one and then the line is the lower value. Okay. So I'm going to go ahead and go in an integral. F of x minus g of x. And then our bounds are going to be from -2 to 1. Now you can, on this graph, that's very easy to see. Now don't just as a word of caution, don't just assume it's -2 and 1. I know that because I've done this problem ahead of time. But what I need you to do is to be doubly sure actually find the intersection point. And then we can clearly see here the intersections at 1 and 2. Because the reason why we do that is because it could be like 1.001. And that would throw off our integral just a little bit. Alright, so I am going to work this one out. I would highly recommend you please put parentheses around both of f and g, just so you don't forget to distribute the negative. So now I don't really need to distribute in this case. So negative 2 to 1, 2 minus x squared minus x dx. And because I am who I am, I want to put everything in order. And what I'm going to do now is I'm going to integrate normally. Oop, I don't need the integral symbol anymore because I am integrating. Negative x cubed over 3 minus x squared over 2 plus 2x. And then we're going to go from negative 2 to 1, plug those values in. Negative 1/3 minus 1/2 plus 2. There's the top bit minus the bottom bit. So negative 2 cubed is negative 8 negative, so it's going to be 8/3. That's going to be positive 4, so positive 4 over 2 is 2. And then negative 2, that's negative minus 4. Okay, simplifying this very quickly, I'm going to go ahead and distribute my negative. The negative 1/3 minus negative 8/3 is negative 9/3. 2, 2, and 4, that's 8. Well, I also have this half here, minus half plus 8. So that becomes negative 3 plus 8 minus half, which is 5 minus half, which is then 9/2. So if we were to find the area between these two curves, this little shaded region right here, it would be 9/2 unit. Okay, and then we can confirm this. So we have both those in there by doing it this way as well. And I want y'all to do both. I want y'all to do it by hand and in the calculator. That is the expectation. And when we do have a quiz or test, which will happen here soon, within the next week, you must submit all your work with it. If you don't submit your work, you will get 0 credit for the assignment. So please keep that in the back of your mind. You must show every step. It's just because we're online, it's just the way we're going to have to do it. So we'll push math 9 from negative 2. So negative 2 to 1. And we're going to do alpha f4 y1 minus y2. Because y1 was our top function, y2 was our bottom function. And then from there we should get 4.5, or as we did, I did as a fraction, 9/2, which is exactly what we got. Okay, so I'm going to go over 2 more examples, and then I'm going to go ahead and give you the homework assignment, and that's what we'll call it for section 7.1.